Hi, my name's Doug Rosendahl, and I'm one of the pilots of the CAF P-51C Tuskegee Airmen. The P-51C is an early model of the Mustang. The first model of the Mustang was the P-51A, and the A model Mustang has an Allison engine, and we built those airplanes and sold a lot of them, or lended a lot of them to the British. And the British, the Allison didn't have a two-stage supercharger, so they were kind of altitude limited, and the British put the Rolls-Royce Merlin engine in the A model, and that was the beginning. That went back to North American, and North American put the Rolls-Royce Merlin in the Mustang, and that became the B and the C. The B model Mustang's built in Inglewood, California, and the C model was built in Dallas, Texas. Otherwise, there's no difference between the airplanes. They're essentially identical. There were a few other differences between the A and the B's and C's, but primarily it was the engine. The fuselage is a little bit taller. They put a joggle in the aileron, or in the longeron, lower longeron, to make the fuselage a little bit deeper, and they put floorboards in the airplane. Just a few cursory upgrades, but the primary difference between the A and the B's and C's was the engine. And then the air intake on the A model was on top, where here we have the carburetor air intake on the Mustang is below the propeller. And then there's a great big long induction trunk that comes all the way down underneath the engine, and then the air turns vertically into the updraft carburetor before it goes into the supercharger. You know, the Merlin's a 12-cylinder, 1,650 cubic inch, 1,490 horsepower engine, and again, it had the two-stage, two-speed supercharger, which gave it a service ceiling of 41,000 feet, which was really what made the difference. It could go up to high altitudes with the bombers. The propeller is a four-blade Hamilton standard hydromatic propeller. It was the first propeller that was developed in multi-engine airplanes which could be featherable. And what's unique about it is, prior to this propeller, propellers typically had oil pressure on one side, and then they used centrifugal force and aerodynamic loads to counteract the oil pressure to control the propeller. The hydromatic propeller had engine oil pressure on one side of the piston and governor pressure on the other side of the piston to positively control, and that's what made it possible to also become a feathering propeller. From this view, you can see that the inner gear doors are hanging down, and that happens when we park the airplane. We dump the hydraulic pressure, and with the gear down, the only thing holding the gear doors up is hydraulic pressure. But they'll move easily. We can push them back up. But because there's no hydraulic pressure on the airplane, they'll fall right back down. That's problematic, because if we lose hydraulic pressure and have to emergency extend the gear, these doors come down and they block the air going into that air intake down there, which is the radiator. And this is a water-cooled engine. That's why it's nice and narrow. It can be a V12, where the radials are all air-cooled, so they need a lot of surface frontal area to get enough cooling through them. So the radiator and the oil cooler are down there in the belly of the airplane, which is another, we'll talk more about that when we get back there, but another reason why this airplane was so efficient is because it just had less drag. Another difference between the C model, A, B, and C model, and the D model is they totally redesigned the gear well and the gear system. Now, this airplane operates just like a D model, but the door is different. In the D model door, you'll see internal door latches, and the door latches here are all external. The door's a little bit bigger. This leading edge of the wing in a D model comes to about here. There's just a little bit bigger fillet to accommodate for all that machinery that's in there. There are pretty significant differences in the way that the C model gear operates and the B's and C's and the D model gear operates. But anyway, there's our hydraulic accumulator right there. That latch fits behind that latch right there. When the gear's up in flight, those latches are engaged. Again, as I said earlier, when it's down, the only thing holding the gear door shut is hydraulic pressure. Out here we can see the main gear actuator. North American airplanes are built with some really ingenious serviceability. You can take that actuator and overhaul it without jacking up the airplane. The way it comes apart is designed for easy servicing in the field, and it's really unique design. The D model airplane has 6 guns, 3 on each side, where the A's, B's, and C's only have 2. And there's some people will tell you that the C model and the B model wing is thinner, but that's not true. They moved the stringers in the wing to a different location so they could stand the guns up vertically so they'd be less likely to jam, and that gave them the room they needed for another gun. The pitot system is different on a D model airplane. The pitot tube on a D model is entirely different. This has got this long mast to get the pitot tube below the wing to get away from the pressure that reads under there. If you're trying to solve an interesting engineering problem, it's always good to look to nature. And the inspiration for this airfoil is a tuna. So if you look at this shape, it is very much shaped like a tuna. And that's a laminar flow creature. And that's why that was the inspiration for the laminar flow ring, which is another reason why this airplane was so efficient.
North American P-51 Mustang.
The ailerons are conventional, but what's unique, and it's hard to see, but on the leading edge of the aileron there's a strip of metal that's bolted to a piece of canvas that's bolted to the fuselage. So this gap is totally aerodynamically sealed. And that's part of why this airplane has such lovely handling characteristics, is there's no aerodynamic spillage in the aileron. Trim tab. Mustang has big flaps, 50-degree flaps, and they are mostly drag flaps. They don't generate a lot. The first notch generates a little lift. After that, it's pretty much all drag. First notch of flaps is at 400 miles an hour, and then it ratchets down. And from 40 to 50, it's 155 miles an hour. These are the gun doors. So the gun was here, and there's a separator in here, and there's a fore and aft ammo bay. This airplane doesn't have the ammo bay in it. This is designed for, we use this for storage. Here's the fuel filler cap. The airplane has 92 gallons aside for a total of 184. Obviously in combat then it had drop tanks under the wings of whatever size they bolted on there. And then there was another 85-gallon tank that fit right here, and then the radio gear set on top of that fuel tank. We've got an extra seat back there for our passengers. Here's the flap actuator. You can see the flaps are hydraulic. North American airplanes are typically hydraulic, and this airplane's no exception. It's a very hydraulic airplane, and that's common. Back here we see this door, and that is the radiator coolant door, and that's electrically adjustable, and it has an automatic thermostatic automatic mode to regulate the engine temperature. Down, the radiator sits right here, and then in front and below the radiator you'll find an oil cooler, and there's another door down under there that again electrically actuated and automatically controlled that regulates the oil temperature.
And I guess there's good reason to feel that.
Tail wheel is steerable when the stick is aft, or aft of about forward, and if you push the stick all the way forward you pull a pin and then the tail wheel becomes castering. So one of the things you always want to be careful of in a Mustang is not to allow the stick to go forward as you're rolling out on. You always keep the stick in your hand and keep it back when you're rolling out on the runway, because if you were to hit a bump, the counterweight on the stick could pull the stick forward, disconnect the tail wheel, and you'd be out in the plowing somewhere. The early model Mustangs like this had fabric tail feathers. Fabric was not a strategic resource, and they knew that lighter controls were less prone to flutter, and so if you got a lighter rudder you can get by with a lighter counterbalance, and so it all just made sense. But later in the war they put metallized control surfaces. But as you can see, this airplane has fabric rudder and ailerons. These are big, heavy counterweights, again, to prevent flutter and counteract the flutter and all of that. Coming around this side, it's really a mirror of the other side. Not much going on here. Our oxygen tank would be in there, and that's about it. One thing that's unique on the Mustang, this is really a unique situation. If you can get in there and see, there's a cable that goes around a drum in there. Bring your camera down and look forward just a little bit. Nope, down this way and look forward, and you might be able to see a round drum. Okay, and that round drum has got an offset angle in it, and so as it rotates, this bell crank right here moves up and down, and that actuates the elevator, and that allows us to get pretty good elevator or aileron displacement without having to put a big bulge on the wing and create drag. So we'll move up towards the canopy here, the cockpit.
Sit in there and I'll shoot over your shoulder.
Okay. So the joke in the Mustang is there's more parts, in the C model Mustang, is there are more parts in this canopy than there are in the rest of the airplane, and that's very likely partially true. It has sliding windows, and it's very fragile, and so we're always careful to not put pressure on that canopy. So this airplane has a very stock cockpit with a few exceptions. One being we replaced the gun mount with a Garmin handheld GPS, and the other is we replaced the attitude indicator with a Garmin solid state horizon because the durability of the old original Horizons just wouldn't stand up to any aerobatics, and so they weren't dependable. And in the interest of safety, we put in a Garmin G5. But the thing you do when you're getting in a Mustang, getting ready to go, is what's called sweep the cockpit. And that starts right back here. Here's our flap handle. The ergonomics of a Mustang cockpit are a thing of beauty. Everything is in a place where your hand falls to it, and it's separated from other controls so you won't get confused. The flap handle's way back here, the gear handle's way forward to prevent collision between those. But it moves, the flaps move in notches, and you just select 10, 20, 30, 40, 50, and hydraulically they extend and go to that level and stay there. Right here you can see again the flap speeds. 10 degrees is 400, 20 degrees 275, 30 degrees 225, 40 degrees 180, and finally 165 for full flaps. The head of the flap handle is the trim console. You have three trims, rudder, elevator, and aileron trim. What's unique about a fighter is that we find ourselves, every time we change pitch or power, we're going to end up going to the rudder trim. You use rudder trim in a fighter almost as much as you use elevator trim, which is unique when you're different coming from other types of airplanes. There's just so much power that as your speed changes, and a lot of rudder, and you're moving back and forth between the rudder and elevator trim all the time. Here's our throttle quadrant. Throttle quadrant is very similar to the D model but different. We've got our throttle control right here, prop control right here, and mixture control down here. On the D model airplane, it's built into a little different system, and it sets up just a little higher. In the D model, they raise the seat up because of the bubble canopy. We got a little bit more room, and that gives you a better visibility. Again, the instrument panel, aside from the handheld GPS here, and the Garmin is very original, all stock. Everything you see here, with those two exceptions, would be stock. Here's our electrical panel over here, and then this is modern radios. Well, they're not exactly modern, but they're current radios, and we control those down here, and we just kind of hide those out of the way to make them make the airplane look authentic. This panel here is not authentic, but this is where we hide some circuit breakers and some emergency fuel switch. This is an interesting switch. This was developed, probably 25 years ago, I suppose now, and it's called an emergency fuel switch. And if your carburetor malfunctions, all you have to do is pull the mixture to idle and turn this switch on, and it'll open a solenoid that will spray a gallon a minute of fuel into the backside of the blower, and the airplane runs perfectly normal at cruise speed until such time that you shut it off, and then it gets quiet. But the carburetors in these old airplanes can be problematic, and here's a really simple way to mitigate some of that risk. Just an emergency fuel switch. Click it on, and you can fly forever without a carb until you run out of fuel or electricity without a carburetor. Down here we have 2 fuel pumps. Originally the airplane had a off and on selection, and it drew out of both tanks simultaneously, or you just turn on the pump on low of whichever tank you wanted to burn out, and there was check valves to prevent cross-feeding. Those check valves would tend to leak a little bit, and so we had fuel balance problems. So we incorporated a D-style fuel selector, but we retained the 2 fuels. So if you want to burn fuel out of the right tank, you select right, and then you turn on the right fuel pump if you're going to start. We don't have to use the fuel pump in flight. That's not necessary unless you're at high altitude, but the D model fuel selector works better. This knob down here is our hydraulic dump. You saw in the belly that the hydraulic gear doors were hanging down, and we pulled this knob out after we shut down to dump the hydraulic pressure, which makes the gear doors fall down, and there's a interlock down there that when the doors are open you cannot move the gear handle. Gear handle's right over here. It's just out of reach, so you kind of got to reach for it, so it's a conscious effort. It breaks to the inside and then you pull it back. That's how that works. So you inboard and then aft, and same is true when it's up. You pull it inboard and push it down. We have a Heinz filter. This is a screen. It's not original, and these 2 lights right here, one says bypass and one says chip. So if the engine starts making metal, there's a small screen, and if that screen plugs, there's a bypass that will open, and if that bypass opens, that light will come on telling us that something's plugging that small screen. So it will plug fairly quickly and give us an alert, and hopefully allow us to get on the ground before the engine completely fails. Above it's a chip light. The chip light is just a little magnetic plug, and if you get a piece of metal on that conducts electricity across that light will come on telling you that there's a piece of metal. That's more of a warning light. There can be small fragments of metal in the oil without being a problem, but if that light comes on, that's a hint that maybe we need to look at some other things. The instruments, we've got a remote electric compass, a clock, a suction vacuum gauge. Over here is our manifold pressure gauge. 61 inches of manifold pressure is normal power. Most people take off between 50 and 55 inches of manifold pressure is kind of normal. Here's our tachometer. 3,000 is the red line, 3,300 in a dive. We want to stay at 3,000, and then we cruise typically somewhere between 23 and 2,400 RPMs, and somewhere between 31 and 35 inches of manifold pressure. Those are good cruise numbers. We got 3-in-1 gauge down here, oil temperature, fuel pressure, and oil pressure. This is our coolant temperature gauge. If you're flying a Mustang and you're not thinking about the cooling system, you're not doing your job. You know, the joke is that a water-cooled airplane makes as much sense as an air-cooled submarine, but it really made the airplane more efficient, and the evenness of the temperature makes it possible to build an engine with tighter tolerances, and so a higher performance engine. But you know, a coolant leak, whether it's from a bullet or a bad hose or a corroded pipe, anything, a coolant leak is a big problem. This engine won't survive moments, a few minutes at most without cooling. And so we're always thinking about the coolant temperature. We saw the coolant doors outside and the oil door. Those are regulated right here, and they have an automatic position, then a manually open and a manually closed over here. And that's true of both the oil and the coolant door, and those are right here. So typically you take off an automatic and climb to altitude, get level, smooth them out, and then you just put the door to manual, and that way if something starts to fluctuate, you'll see it in the temperature gauge, and hopefully that'll give you some warning before you have a real problem. This down here is a control lock. It pulls out and forward, and then the stick is free. The Mustang has lovely flying characteristics. The one gripe that we all have about a Mustang is as you get going fast, the ailerons get heavy. And that's both a little bit annoying, but it's also a safety factor. You know, if you feel the ailerons getting heavy, you need to take a look at the airspeed indicator. You're probably going too fast. Other than that, you know, I mean, you've heard it from a million pilots that have flown the Mustang, but it's an airplane that's a part of you. It's just a great airplane, and it's a real honor and a privilege to be able to fly it. So we have an emergency canopy release right here. You pull this, and it pulls some pins, and this entire wrapper around here is released. The way that works is this notch right here comes forward, and there's two fingers right there that will pop up, and that'll release all this mechanism, and all that will be gone on both sides. O2 regulator right here. That's a World War II oxygen regulator, and for higher altitude flying. Thanks for watching. We hope you enjoyed a tour of the CAF P-51C Tuskegee Airmen.